Hi everyone. Today's lesson is about skew lines and shortest distance between two skew lines. So let us start the class. Let me share my screen. Just one sec. Yeah, so skew lines is basically we define skew lines in 3D space. So in three-dimensional geometry, skew lines are two lines that are neither parallel nor intersecting. Yeah. So, but whenever we draw two lines in the plane, specifically, you can say on the blackboard or in the notebook or any screen. So, basically, drawing two lines in the plane means we can see whether the lines are parallel or intersecting, right? But here we are talking about two lines that are neither parallel nor intersecting. So, what I understood from this, the skew lines are not lying on the same plane. Like, for example, you can see in this figure, so two lines, so they are in different planes. So, skew lines are non-coplanar. It means they do not exist in same plane. Or you can say skew lines exist in different planes. And also we can just extending the concept a little bit more. Skew lines can only exist in a dimension higher than 2D. Yeah, higher than 2 dimensions. Now, how they look like? Let me show you how skew lines look like. Yeah, so this is a more popular GeoGebra applet. You can see these two lines here. One is in green color, one is blue color. Blue color. So we are talking about these two lines. Yeah, and the line L1 passing through A and line L2 passing through B. As we are familiar with the equation of the lines, and by looking at the equation of the line, we can say whether the lines are skew lines or parallel lines or intersecting lines. We can identify whether the two lines are parallel or not. Okay, but unless we check it, we can't say whether two lines are skew lines or two lines are intersecting lines. So in general, we take like the lines vector equation like R equal to vector A plus lambda times vector B. And similarly, L2, we take it as R equal to A2 plus mu into B2. Just like I can show you here, like this. So we have two lines L1 equal to, equation of L1 is R vector equals to A1 plus lambda B1. So A1 is, through A1, the line L1 passes. Yeah, and B1 is a vector to which line is parallel to. Similarly, L2 is the line which passing through the point whose position vector is A2 and it is parallel to B2. Or we can say B1 as the direction vector of L1. B2 is direction vector of L2. We may, say that also. So here you can see, like whenever you take L1, L2, like this. So this you are familiar with. We are just coming back to this point in a while. So now you see how they look like. Now the lines are in different planes. You can see whenever you just, so they are not intersecting. They are in different planes. Okay. So the green line is in one plane and the blue one is another plane. So they are like this. You can see they will not they are not intersecting, and also they are not parallel. So the skew lines look like this. Okay. Now here, yeah. So shortest distance between the skew lines means what? Shortest distance between the two lines means, yeah, the line of shortest distance between two skew lines means the line which is perpendicular to both the lines. Now you just look at this line. If I take this one, So this is the line joining the point A from L1 and point B from L2. Okay, but this is not the shortest distance, right? So you can say just distance between these 2 points. And similarly, you can see here, yeah, the shortest distance between it looks like this, you can see. Okay, yeah, so the line which is perpendicular to both L1 and L2. Okay, now here I can show you, yeah, so regarding direction, so as we know, line L1 is parallel to vector B1, right? So, or you can say B1 is the direction vector of L1. Similarly, line L2 parallel to vector B2, or B2 is direction vector of L2. Now, the vector which is perpendicular to both A and B, that vector is A cross B. So it means if we say the line which is perpendicular to both L1 and L2 means the line which is perpendicular to both B1 vector and B2 vector, it goes like this. Okay, so it is basically B1 cross B2. Now line of shortest distance will be acting in this line, but that will be again the distance between L1 and L2, and this line of shortest distance is perpendicular to both the lines. Okay, so you can see the position when you change the distance. Okay, so now going back to our class notes. Yeah. So, so basically we want to get this distance, right? Let me take it as, yeah, this is one of the positions, in fact. Now, if I take yeah, AB, so AB distance, yeah, distance between A and B is magnitude of AB vector. So AB vector is what? Position vector of B minus position vector of A, means we can write here A2 vector minus A1 vector. Fine. Now, if you look at this triangle, no, so this length, this is projection of AB on B1 cross B2, because B1 cross B2 is the vector which is perpendicular to both B1 and B2, or in other words, B1 cross B2 is the vector which is perpendicular to both L1 and L2 lines. Okay, now this dotted portion means the lines shown is black dots. So this much is the shortest distance between the lines. And this portion, I mean this line is perpendicular to both L1 and L2. Obviously, it is in the direction of B1 cross B2. Or if you look at this triangle, no, you can see this length means if I name it maybe AP, or I can just this length, basically this is projection of A2 minus A1. This length is your A2 vector minus A1 vector. So this is projection of A2 minus A1 on B1 cross B2 vector. And we know projection of A on B is A dot B divided by magnitude of B. Here, the line of shortest distance is, yeah, this shortest distance, I can write it as SD, is projection of A2 minus A1 on B1 cross B2 vector. So applying the scalar projection formula, we can have A2 minus A1 dot B1 cross B2 divided by magnitude of B1 cross B2. Fine. So distance can't be negative, so we can just put the modulus sign here. So the shortest distance between skew lines L1 and L2 is scalar projection of, or simply you can say projection of a vector A. Means you can say in this case It is projection of A2 minus A1 onto vector. This B means here it is B1 cross B2, right? So we are using this formula used for projection. Here it is like this: A2 minus A1 dot B1 cross B2 divided by magnitude of B1 cross B2. So hope it is clear. So you visualized, you could see the skew lines, how they are neither parallel then neither parallel nor intersecting, and also how to find the distance between two skew lines. Now, as I said earlier, whenever you look at the equation of the line, you can't distinguish whether the lines are skew or non-skew. Okay, so in case the lines are intersecting, the shortest distance between them is 0, right? And in case of parallel lines, though you can identify lines are parallel, because when the lines are parallel, the direction ratios are proportional. Or you may see L1 can be like this and L2 can be like this. Okay, now R equal to A1 plus lambda B and R equal to A2 plus mu B. So even if it is given in B1 and B2 form, but you can check whether the direction ratios of B1, B2 proportional or not. Okay, in case of parallel lines, you can find the direction ratios are proportional, then you can change it into in this form, right? Now the figure is looking like this. So we want shortest distance between two parallel lines, means this PT, length of PT. Now you look at this diagram. Now theta is here, like A2 minus A1, just like the previous case you can find. Now in this triangle, you can see sine theta equal to what? Sine theta equal to PT divided by this ST. Okay, PT by ST, or magnitude of this, magnitude of this. Okay, now here, so the dot product of B and ST means ST is the vector joining this point and this point, right? A2 minus A1, basically. So as we know, the cross product of B and ST can be taken like this: magnitude of B into magnitude of ST into sine theta into n cap. So n cap is the unit vector perpendicular to both B and ST. Okay, now here the distance ST can be written like this. Yeah, ST equal to A2 minus A1, position vector of T minus position vector of S. Now here sine theta, as we just discussed, a magnitude of PT over ST. So PT is magnitude of ST into sine theta. Right? Now here you can see, now the equation 1 we have B cross ST, this cross product of these two vectors is magnitude of B into magnitude of PT into n cap. So magnitude of this cross product is, like you can see this one. Okay, magnitude of B cross ST is magnitude of B into magnitude of PT. And we can replace ST by A2 minus A1. So it means you can have B cross vector A2 minus A1. The magnitude of this cross product is magnitude of B into magnitude of PT. This gives us magnitude of PT is magnitude of B cross A2 minus A1 divided by magnitude of B. So as we discussed, PT, this length is the shortest distance between two parallel lines. So basically distance between the parallel lines L1 and L2. Fine. Now here we can conclude like this: the distance between two parallel lines in 3D space is given by magnitude of B cross A2 minus A1 divided by magnitude of B. And we know what is A1, what is A2, and what is B vector. Yeah. So I hope it is clear. And this is one of the very, very important concepts in 3D geometry and specifically for 12th standard board exam. Yeah. Thank you so much.